Hi everyone, welcome to the review session, or welcome to watch the review session recording. Okay, so uh, so you asked number 6 in the practice exam. So let's look at number 6 first. Okay, number 6. So here, solve the following equations. Give both and exact solutions and an approximation rounded off to the nearest thousands. Show your work. Okay, so the part A, this is a equation involving exponential expression, right? And because here we have two exponential expressions, right? And they have different base. So therefore, what we do is apply ln on both sides, okay? And then you see, when we apply ln on both sides, left hand side we get ln 5 to the 2x. Right hand side we have ln 7 to the 3x plus 8. Right? We apply ln on both sides. And then using the property of ln. So what are the property of ln? So ln of p plus ln of q, that is ln of p times q. So we can combine the sum into a product inside the ln. And we can combine subtraction into quotient inside the ln. So p over q. Okay, that's the properties of ln. And when you see some power, you can move the power down in front. So m times ln of a, right? And we also have like change base formula for like any base. We can change base formula. We can use ln to be the new base. Then this is ln of a over the ln of the old base, which is b. And furthermore, we have the formula log b to the n and of a to the m. Here we can put the m in front, okay, but it's in the numerator. And we can also put the n in front, but it's gonna be in the denominator. Okay, so these are all the properties of the log. Now we apply ln on both sides. So the exponents, we can move it in front. So we get 2x times ln of 5. And then here we move it down in front. So we get 3x plus 8 multiplied by ln of 7. And be careful, the common mistake is students might forget about the parentheses. If we forget the parentheses, then that would be wrong, so be careful. And then now we continue. So usually we put we group all the coefficients in front of x, right? So you can like switch the x and ln. Okay, you group the 2 and ln together so the coefficients are in front of x. And then on the right hand side, we can distribute. So we get 3x times ln of 7 plus 8 times ln of 7. And then, you see, this is 2 ln of 5x. And we can also switch the position of x and ln of 7 because this is multiplication. Multiplication is commutative. We switched order, that's okay. Now we can put 3 ln of 7 together, and then that's x plus 8 ln of 7. Okay, so the second step, we distribute, right? We distribute or multiply out. And then what we should do, because we want to solve for x, so we move all the terms with x to the left hand side, and we move all the terms without x to the right hand side. Okay, so that is the third step. And here we can see on the left hand side, this guy has x, so we keep it on the left hand side. And then on the right hand side, this guy has the x, so we want to move to the left. By moving, we mean we want to subtract 3 ln of 7 x on both sides. Now the left hand side, we have 2 ln of 5x minus 3 ln of 7 times x equals the right hand side, we have 8 ln of 7. And now, do you see left hand side? Because all the terms on the left hand side has x. So we can factor the x on the left hand side. So we factor out the x. We get 2 ln of 5 minus 3 ln of 7 equals 8 ln of 7. Finally, x is both sides divided by that giant factor. So 8 ln of 7 divided by this guy. So 2 ln of 5 minus 3 ln of 7. Okay, so this is how we get the answer. And this answer is exact. So how do you type in your calculator? Let me see. So calculator. Okay, so make sure you know how to use your calculator. Right now, let's type in the online calculator. So we have what? 8 ln of 7. So 8 ln, where's ln? Here, ln of 7, parentheses, and then what? Over 2 ln of 5. So divided by 2 ln of 5, parentheses, minus, so, and then, 3 ln of 7. So 3, oops, you see, be careful. Now my 3, we want it to be down there. So 3 ln of 7. And then close parentheses. See, our answer, negative 5.944. So negative 5.944. Okay, so make sure all of you try to put this in your calculator. It's very important to make sure you know how to use your calculator. Okay, so this is part A of problem 6. Any questions about this problem? You got something different. Oh, what do you get? Please feel free to unmute. Let me check my solution. 6.689. Let's see. Okay, the practice exam. Do I have the same answer before? Okay. So, yeah, so this is what I got before. Let me see. Do I need to put parentheses somewhere? Yeah, of course. So how do you type in your calculator? You put 8 ln, and then usually when you press the ln button, then you press the 7, and then you need to put a parentheses. And then you put divide. Then you need to put a parentheses. So you put 2 ln, and then that will give you a parentheses. You put 5, close that parentheses, minus 3 ln, then it will give you a parentheses. You put 7, close that parentheses. One more parenthesis. So make sure you have those 2 parentheses. So probably that is the mistake. Do you have the same expression as this? 8 ln of 7 over 2 ln of 5 minus 3 ln of 7? Or you can feel free to take a picture of your work and then email to me. Okay, then I can see what's the mistake and email back to you. Yes, I just added the same answer. Yes, awesome. Yes, that's great. So that's why I hope all of you can try to put these answers in your calculator and make sure you get the correct answer. Yes. Yes, it's very important to know how to use your calculator. Okay. So that is part A. Any questions about problem 6, part A? Are we all good? Now let's look at part B. Okay. So part B. Do you see we only have one exponential expression? Okay. The last problem, we have 2 exponential expressions. Then we apply ln. But here we have only one exponential expression. Well, in this case, we're gonna isolate the exponential term first. Okay? Isolate means we want to have that exponential term on one side by itself. Okay? Therefore, all the other numbers move to the right-hand side. So that's why, see, we want to get rid of the a, get rid of the minus 5. So what do we do first? We add 5 on both sides. So we have 8 times 3 to the 5x plus 4 equals 44 plus 5 is 49. Okay? By the way, can we multiply the 8 and 3 together? No, we don't multiply them together because they have the different exponents. So we cannot multiply them if they have different exponents. Okay, so now we want to isolate. So we want to get rid of the 8. So both sides divided by 8. We get 3 to the 5x plus 4 equals 49 over 8. So far, so good, everybody? And then we apply ln, okay? So apply ln on both sides. Okay, you might ask, can we apply log 3 on both sides? The thing is, in your calculator, you don't have log base 3. So why don't we just use ln? Okay, make things simple. Just use ln. Don't use log with different base. Just use ln. So ln 3 to the 5x plus 4 equals ln of 49 over 8. Okay, so now, because of the properties of ln, so for those of you coming late, we review that ln, we combine the sum, and then we get the product inside the ln. And subtraction of ln's, we can combine subtraction, and then we get ln of division. And then ln of a to the m, we can move the power down in front. So it's m ln of a. And then this is a change base formula. Okay, so change base. And that's how you use your calculator, because your calculator only has ln and log, which is base 10. So any base log base b, a, that's ln of a over ln of b. Shouldn't there be parentheses after the first in front of the 3 to the 5? Oh, okay, like here. You can put parentheses, or if you don't put parentheses, that's okay. They mean the same thing. Right. If you have something like the 3 times 5, then this is confusing because we don't know. Oh, this is like ln of 3 times 5, or is ln of 3 times 5. So this is confusion. But if we have ln 3 to the 5, this is okay. The 5 is on the exponent of 3. So then this means this is ln of 3 to the 5. Yes. So in this case, whether we put parentheses or not, uh, doesn't matter. They mean the same thing. Okay. But if it helps you to understand better, you love to put parentheses, please feel free to put parentheses. Yeah. Okay. So, and then the last property of ln, log b to the n of a to the m, we can put the m in front, but is in the numerator. We can put the n is the exponent of the base b, right? We put in front, then it actually becomes the denominator. Okay, so these are the properties of ln. So that's why here we can move this down in front. And we get 5x plus 4. Don't forget the parentheses. That's really, really important. Okay, now we want to solve for x. So one way you distribute, but I think it's easier to both sides divided by ln of 3. Then we can get rid of that. We get 5x plus 4 equals ln of 49 over 8 over ln of 3. And in the quiz, remember when I show you the solution, I also show you different ways to solve the problem. So I saw different ways to solve the equations involving exponential expression and log expressions. So all of those ways are correct. Okay, so you don't have to use this way. If you use a different way and you still get the right answer, that's fine. Okay, now continue. We can subtract both sides by 4. We get 5x equals ln of 49 over 8 divided by ln of 3. And we subtract 4. Finally, both sides divided by 5. Okay, so this is what we get. And now we input in our calculator. Well, you gotta be careful because how do you input your calculator? You put parentheses, ln, and then you put 49 divided by 8, close parentheses, and then divided by ln 3, close parentheses, and then subtract 4, close parentheses. So this means the whole numerator, and then divided by 5. Okay, so this is how you input in your calculator. So let's use our online calculator. What do we get? ln of 49 over 8. Okay, so ln of 49 over 8. And then, what's that? Next, divided by ln of 3. So divided by ln of 3, close parentheses, and then minus 4, and then divided by 5. So minus 4. Oh, then you see, I missed a parentheses. So I can input parentheses and go back, input that parentheses. Now divided by 5. Our answer is negative 0.470. So negative 0.470. So far, so good, everybody. So that is part B. Do you have the same answer? Are we all good? Okay, how about if you can understand, could you type 1 in the chat? If you can understand, could you type 1 in the chat? Thank you. Great. And if you have questions, please feel free to unmute and ask. Good. All right. Let's continue. So part C. Oh, by the way, yeah, we start the review session at 8, and then we go to problem 6. So we haven't go over the previous problems. So when we have time, we will go back. Okay. So I basically want to go over the problems you asked me first. So some of you asked me problem 6, so that's why we're going over problem 6 first. Okay, log properties. We combine subtractions into division. So this is subtraction, like your quiz. Okay, so we combine the subtraction into division. So the division is inside the log. Okay, so log 3x plus 5 and over ax minus 1. Okay, and that's the left hand side. So subtraction, we get division. Okay, if the problem asks you log 3x plus 5 plus log 3 ax minus 1 equals 2. If this is plus, then you combine additions into a product. Okay, so this is a product. Okay, be careful. So it's really important whether it's subtraction or addition. Okay, after we combine into a single log. So first we combine into a single log, and then we can both sides. Here, this is log base 3, so both sides apply 3 to the power. Okay, so 3 to the log 3x plus 5 over ax minus 1 equals 3 squared. Right, everybody? Okay, and then 3 and log 3 cancel. So we have 3x plus 5 over 8x minus 1 equals 3 squared. That is 9. Okay, so we want to solve for x. Get rid of the denominator. Okay, so both sides multiply by the denominator. We get 3x plus 5 equals 9 times 8x minus 1. Okay, and then what do we do? Distribute. So 3x plus 5 distributes. 9 times 8 is 72x. 9 times minus 1 is minus 9. Okay, so we want to move all the x on one side and the constant term on the other side. Well, because 72x is bigger than 3x, so it's better to subtract 3x on both sides. Then we get 5 equals 72 minus 3 is 69x minus 9. And then we move the constant to the left hand side. So we add 9 on both sides. 9 plus 5 is 14. 14 equals 69x. Therefore, x is both sides divided by 69. So x is 14 over 69. Okay, so make sure you bring your calculator because this is the exact answer, and then you need to use your calculator to approximate your answer into 3 decimal places. So 14 over 69.203. And are we done? Not yet. For equation involving exponential expression, we don't need to check our answer because the domain for exponential function is all real numbers. But for equation involving log, after we get the answer, we always need to check. Remember your quiz? Many of you forget to check. That's why I took 0.5 off. In the exam, if you forget to check, maybe it's 1 point off, maybe it's 2 points off. Okay, so check. Look at all the log expression. So log 3, 3x. X is 0.203 plus 5. This is okay. The things inside the log is positive. And then log 3, ax minus 1. You know, a times 0.2, this is about 1.6. 1.6 minus 1 is 0.6. That's positive. So that's okay. So our final answer, x equals to 14 over 9, is a solution. Okay, so make sure we check that. So far, so good, everybody? Okay, so we've finished problem 6. Which problem you want to go over next? Feel free to ask me questions on your practice exam or your homework. Just unmute. So, do you want to do problem 7? Which problem do you want to go? Three. Okay. 3. Oh, yes, this is a good problem. Okay. So find the complete factorization of p of x and list all the zeros. So how do we solve this problem? So this is a degree 3 polynomial. Okay, then we use the rational roots theorem to find one root. Then use long division or synthetic division to find all the factors. Okay. Let's see, what's rational roots theorem? Rational roots theorem tells us that we look at the factors of the constant term. Here, the constant term is 3. So factors of the constant term 3 always start with plus or minus 1. And then next factor, plus or minus 3, right, everybody? Integer factor, plus or minus 1, plus or minus 3. And then we look at factors of the leading coefficient. See, the leading coefficient is 2. Factors of 2, we always start with plus or minus 1, and then plus or minus 2. Then according to the rational roots theorem, the possible roots are, we use these numbers divided by these numbers. So plus or minus 1 over plus or minus 1 is plus or minus 1. Plus or minus 3 over plus or minus 1 is plus or minus 3. And then plus or minus 1 over plus or minus 2 is plus or minus 1/2. And then plus or minus 3 over plus or minus 2 is plus or minus 3/2. So these are all the possible roots. So rational roots theorem tells us that if the polynomial has a rational root, it must be from this list. Okay, so therefore we try all these numbers and until we find one rational root. So try x equals to
Miss?
yes. Yes.
I did P over Q, and then I did plus or minus 1 comma plus or minus 3 over plus or minus 1 plus comma plus or minus 2. Is that okay?
So you have like plus or minus 1 over plus or minus 1, you get plus or minus 1, right? And plus or minus 3 over plus minus 1 is the same as plus or minus 3 because 3 divided by 1 is 3. And
Okay.
then what else do you get? Do you get plus or minus?
No, I didn't do
Sorry,
that.
what did you?
I did it like, okay, P over Q.
Yeah, P over Q.
Yeah, and then I just did plus or minus 1 comma plus or minus 3 divided by plus or minus 1 comma plus or minus 2.
Oh no, okay. What does that mean by P over Q? You use all the possible P and divide it by all the possible Q. But you have to calculate what that is. So plus or minus 1 over plus or minus 1 is plus or minus 1. Plus or minus 3 over plus or minus 1 is plus or minus 3, right? And then you use plus or minus 1 over plus or minus 2. So plus or minus 1 over plus or minus 2, you get plus or minus 1/2. And finally, plus or minus 3 over plus or minus 2, you get plus or minus 3/2. So that's how you get all the possible roots.
Okay, thank you.
You're welcome. It's great that you figured out now. Yes. Okay, so we try x equals 1. So P of 1 is, we plug in x is 1, and see, we have 1 cube. 1 cube is 1, right? Minus 5 times 1 square. 1 square is 1. Minus 4 times 1 and plus 3. Oh, what's that? Well, 2 minus 5 minus 4 plus 3. Do you see 2, 3 is 5, and then we get minus 4. So this is negative, which is not 0. So 1 is not a root. Keep going. Next one, negative 1. When we plug in negative 1, negative 1 cube is negative 1. Is that okay, everybody? Negative 1 square is 1. Minus 4 times negative 1 plus 3. So we have negative 2 minus 5. And then this has become plus 4 and plus 3. Oh, how nice. This is negative 7 plus 7. This is 0. So x equals minus 1 is a root. So we know our polynomial has the factor x plus 1. Okay, so minus 1 is a root, then the opposite sign. So x plus 1 is a factor. And then to find the remaining quadratic factor, we either use long division or synthetic division. Okay, so in this example, synthetic division is easier. So you put the root is negative 1. So you put the root right here. And then our polynomial, 2x cubed negative 5x squared minus 4x plus 3. Okay, you put down all the coefficients. And then, oops, sorry. Okay, so we move the 2 down. And then 2 times negative 1 is negative 2. We move it here, right? Negative 5 times plus negative 2 is negative 7. And then minus 7 times minus 1 is 7. Put it right here. Negative 4 add 7 is 3. 3 times negative 1 is negative 3. Put it right here. Add them. Do you get remainder is 0? That's always the case because x plus 1 is a factor of p of x. So the quotient, this is the quotient. So we get 2x squared minus 7x plus 3. Now put the quotient right here. 2x squared minus 7x plus 3. So we use rational roots theorem to find one rational roots, and then use synthetic division or long division to find the factors. Once you get the quadratic factor, you either factor it or use quadratic formula. Let's see, can we factor it? Looks like we can, right? We can do it. So we get 2x and x. And the factors of 3, they're 1 and 3, or minus 1 and minus 3. And you want to have minus 7x. So that's why you put negative 3 and minus 1. Negative 3 times 2x is negative 6x. And negative 1 times x is negative x. When you add them, you get minus 7x. So this is how we factor it, right? The zeros, the roots are negative 1. And then here, 2x minus 1 is 0. X is what? We add 1 on both sides, divided by 2, right? And then the last factor, x minus 3, is 0. So x equals 3. And do you see 1/2? 1/2 is actually a rational number, is in our list. And 3 is a rational number, is also in our list. So if we have rational roots, they must be in the list. But in your exam, you might not have all like rational roots. You might have irrational roots, or you might have complex roots. Okay? So therefore, remember the quadratic formula. Quadratic formula, what is that? Negative b plus or minus b squared minus 4ac over 2a. Okay, you use this formula to find irrational roots and complex roots. And then we finish the problem. We list all the zeros. And you can see all of them has multiplicity 1. Remember, multiplicity is the exponent of the factor. And all of them has multiplicity. So all have multiplicity 1. Okay, so that is problem 3. So any questions on problem 3? Are we all good? If you can understand problem 3, could you type 3 in the chat? Thank you. Great. So now we finished problem 6 and problem 3 on the exam. What is the next problem you want to go over? So what is the next problem you want to go over? Seven. Great. Oh, problem 4 has a lot of points too. So make sure you remember all the steps for problem 4. Okay, problem 7. Yeah, problem 7 has a lot of points too. Okay. All right. Now here we want to grab the function negative 3 log x plus 4 minus 2 in the grid below. Okay. And then we also want to write down the domain and range and asymptotes. Okay, so keep in mind log, okay, log or ln, they all look like that. So this is log ln x or log x, they all look similar. It passes through the points 1, 0, and it has the vertical asymptote. The vertical asymptote is x equals 0. So this is the vertical asymptote. And then in the exam, you might have log or you might have exponential function. So e to the x looks like this. And it passes through 0, 1. Okay? And in this case, you have horizontal asymptote y equals 0. Okay, so those are your parent function. Make sure you can remember these parent functions. So right now we have the log. So therefore our parent function is y equals log x. Okay, and it passed through the 1, 0. Okay, it passed through 1, 0, and then it looks like that. Okay, and we have a vertical asymptote right here. So that is our parent function. Okay. Make sure you draw the key point. The key point is 1, 0. And make sure you draw the dashed line, the vertical asymptote, x equal to 0. All right. And then transformations. What are the order of transformations? So let's review. First steps, we shift left or right. Shift left is plus, shift right minus. Okay, and then second step, we reflect over the y-axis, which means you will see there is a minus sign in front of x. And then the next step is reflection over the x-axis, which means you have a minus sign in front of the whole function, or vertical stretch, which means you will see a number multiply the whole function. And then the fourth step is shift up or down, right? Okay. Now let's see here. Do we have shift left or right? Yes, we do. So x plus 4, see? So y equals log x plus 4. Plus is left, minus is right. So we shift left 4 units. Now look at the graph. Look at our key point. See our key point right here. 1, 2, 3, 4. So this is -3. Okay, so -3, 0. And then how about our vertical line? Our vertical line shift 4 units. See, is right here at -4. And then if you want to like draw it, the shape stay the same. Okay, maybe you can use this point as a reference point. We shift 4 units, so it's like right here. Okay, and then you connect them together. So this is what we get. Shift left 4 units. And then next, do we have reflection over the y-axis? Do you see a minus sign in front of x? Do you see a minus sign in front of x? No, right, everybody? We don't see a minus sign right in front of x. But we do see a minus sign in front of the whole function. Well, then that is what? So we have a minus sign in front of the whole function. So that is reflection over the x-axis. Okay, reflection over the x-axis. Look at the key points. See, the y coordinate is 0. So then when we flip it down, it remain the same. So -3, 0 stay the same. Look at my vertical asymptote. We flip it down, it's still the same, -4. But look at this point. We flip it down, it's right down there. So we connect them together. So this is what we get. Okay, so we flip it downstairs. So we flip it across x-axis. Okay, next, do we have vertical stretch? Do you see a number multiplied by the whole function? Yes, you see the 3? Right, we multiply the whole function by 3. So y is -3 log x plus 4. Okay, so vertical stretch by a factor of 3. Okay, so let's see that point, that key point, -3, 0. Because your y coordinate is 0. 0 multiplied by 3 is still 0. And then the vertical asymptote at -4 stay the same. But look at our key points. Our key point, look at this guy. This it was like -3, but when we multiply by 3, it becomes -9. Yeah? -9 is right here. Okay. And then we connect them. So this is what we get. Okay. So by the way, I'm not saying the function must pass through this point 1, -1. This is just a sketch. Okay, at least you can see the difference between that one and that one. You can see the shape is like stretched by a factor of 3. Okay, I just pick some points and then you roughly multiply the y coordinate by 3 to stretch it. Okay. All right. And then next, do we have shift up and down? In this case, yeah, subtract 2. So shift down 2 units. So y equals -3 log x plus 4. Subtract 2. Shift down 2 units. Okay, now let's see. Look at our key points. Shift down 2 units is at -3 and -2. Our vertical asymptote with shift down is the same vertical asymptote at -4. Look at this point. We shift down 2 units. Oh, it's right here. So, and then we connect them. So this is what the graph look like. Okay? And now domain, you see? Domain. So you kind of project this on the x-axis. Domain will be that. Can you imagine the shadow? Yes, the shadow. Okay, the sun is right here. That's the sun. And you project this graph on the x-axis. This is the domain. So domain is from -4, but not included the 4. Not included -4 and go to infinity. That's the domain. And range. Range, when you project on the y-axis, you see the y-axis is the whole y-axis. So minus infinity to infinity. And vertical asymptote. Yeah, we do have vertical asymptote at y equals, sorry, not y equals, x equals -4. So vertical asymptote, they are lines. So vertical lines, x equals to a number. Horizontal lines, y equals to a number. And in this case, we don't have horizontal asymptotes. So no horizontal asymptotes. Okay, so that is problem 7. So my suggestions, okay, exercise. Let me just make up some problem. How about -5 e to the negative x plus 4 -3. I just make it up. So try this at home. Okay, so try this. then this problem, you see, the parent function is e to the x. It's passed through 0, 1, and it has the horizontal asymptote y equals to 0. That's your parent function, and then you go along the list. Yeah, shift left or right, reflection over the y-axis, reflection over the x-axis, vertical stretch, shift up or down. Okay, so try this problem. In the exam, I'm going to ask you exponential function or log function. You don't know which one. So please be prepared for both kinds of problems. Okay, so that is problem 7. Any questions on problem 7? If you can understand problem 7, could you type 7 in the chat? Great. Okay, so make sure, so even though we go over the answer today, and I still hope you can try your practice exam more times. Make sure you can memorize all the steps. Problem 4, please. Sure, problem 4. Yeah, problem 4 is a lot of points. And we have a lot of steps. Okay, so step 1 is to factor. But this is already factored. Okay, so if you have like harder problems, like quadratic factor, then you want to factor further, so you can have a product of linear factors. Okay, so the first steps, I would say factor. And now, let's see, go along the list. How do we find x-intercept? To find x-intercept, we set the numerator equal to 0. Our numerator is 7x minus 14. Set it equal to 0. Solve for x. See? We add 14 on both sides. We get 7x equals 14. And then what do we do? Divided by 7. So we get x equals to 2. Remember. X-intercepts, they are points. If you just write down a number or equation means is a vertical line. X-intercept is a point, not a vertical line. So you should put x-intercept is 2, 0. Okay, I told you so many times. I hope you can remember on your exam. That's x-intercept. How about y-intercept? Y-intercept, you plug in x is 0. See, x is 0. So in our problem, you plug in x is 0. So 7 times x is 0. Minus 14 over 3 times x, but x is 0, plus 18. You see, 7 times 0 is 0, 3 times 0 is 0, negative 14 over 18. 2 is a common factor. 14 is like 2 times 7. Now 18 is 9 times 2, so we cancel the 2. We get negative 7 over 9. And that is the y-coordinates, but y-intercepts, they are points, not a vertical line, not a horizontal line, not a number, it's a point. So x-coordinate is 0, y-coordinate is negative 7 over 9. So that is y-intercept. And then part C, how do we find vertical asymptote? We set the denominator equal to 0. Okay, denominator 3x plus 18 equal to 0. So 3x, subtract 18 on both sides, we get 3x equals negative 18. And then both sides divided by 3, we get x equals negative 6. This might be a vertical asymptote, but we need to check. How do we check? we need to check the behavior when we get close to -6. So we need to check when x approaches -6 from the right, what happened? And when x approaches -6 from the left, what happened? And you know, x goes to -6 from the right, then you know the 3x plus 18, it goes to 0 from the right as well. Okay? Yeah, because this guy corresponds to the factor x plus 6, and you know 3x plus 18 is like 3 times x plus 6, so that's why x plus 6 will go to 0 plus, and 3 times 0 plus is 0 plus. That's why 3x plus 18 still goes to 0 plus. Now how about the y? The y goes to, in this case we look at the factor form. But because in this problem is already factor, so we just look at here, 7x minus 14. X is -6. So 7x, x is -6, minus 14. Over 3x plus 3x plus 18 goes to 0 plus. Now, do you see the numerator? 7 times -6 is a negative number. We subtract 14 is still a negative number. So a negative number over 0 plus, it goes to minus infinity. Yeah, negative number over 0 plus goes to minus infinity. And then how about x goes to -6 from the left? Then the 3x plus 18 will go to 0 from the left. So y goes to, you see the numerator, still the same thing. 7, -6, minus 14, still a negative number. But now it's over 0 minus. You see, negative number over 0 minus is actually positive infinity. Okay, so, if we approach that number from the left or from the right, and we have the y actually goes to infinity or minus infinity. This shows that x equals this shows that x equals -6 is actually a vertical asymptote. Okay, so you have to show the behaviors when x approaching -6 from the left and from the right. Okay, that's very, very important. And then part D, horizontal asymptotes. Okay, so you have horizontal asymptotes. So let me write it down. Okay, so if degree of the numerator is less than or equal to the degree of the denominator, we get horizontal asymptote for sure. If degree of the numerator equals 1 plus the degree of the denominator, we get slant asymptotes. Okay, so in this case, because the degree of the numerator is 1, the degree of the denominator is also 1, so the degree are the same, right? So we have horizontal asymptotes. To find horizontal asymptote, we let x goes to infinity. And we also let x goes to minus infinity. And look at the y. When x goes to infinity or minus infinity, we look at the dominant term. Dominant term is the highest power term in the numerator and denominator. So in the numerator, 7x is the highest power term. In the denominator, 3x is the highest power term. So the dominant term of the numerator, you can put dominant term of numerator is 7x. Dominant term of denominator is 3x. That's why y behaves like 7x over 3x. Now you see the x cancel. That's 7 over 3. And similarly, when x goes to minus infinity, y also behaves like 7 over 3. Okay, so therefore, if x goes to infinity or y goes to infinity, goes to a number, then we say horizontal asymptote is y equals 7 over 3. Okay, so we do have horizontal asymptotes. In the class notes, you can see what happened when we have a slant asymptote. You use long division or synthetic division. Okay, then you can get the quotient. The quotient is the slant asymptotes. So this is in session 3.7. So please feel free to review the notes. Okay. Now keep going. We're ready to draw the picture. So let's draw the picture. X-axis, Y-axis. Look at part A. X-intercept 2, 0. 2, 0. Right here. By the way, you don't need to put a lot of bar there. You don't need to. Okay, just put 1 point and say label it. That's 2. You can make the graph simple. And then y-intercept 0, negative 7 over 9. So we know it's negative. So we just put a number here and say this is negative 7 over 9. Okay, so that's the y-intercept. And then vertical asymptote, negative 6. So let's say negative 6 is right here. They don't have to be very precise graph. The scale must be the same. No, you don't have to. Okay, so vertical asymptote, put dash line. And let's look at when x goes to minus 6 from the right. See, from the right, my y goes to minus infinity. Minus infinity is top or bottom. Think for 2 seconds. Top or bottom? Bottom. Minus infinity, down, below. Okay. How about when x goes to minus 6 from the left? My y goes to infinity. Infinity is top or bottom? Think for 2 seconds. Top, right? Okay, so you put the dots there. And then when x goes to infinity, y goes to 7 over 3, 7/3. So that's the horizontal asymptotes. 7/3 is bigger than 0. So on top of the x-axis, draw the dashed line. Okay, and when x goes to infinity, we approach to this line. How do we approach it? We don't know. So you put a pair of points there. You don't know we are approaching from the top or from the bottom. We don't know. You just put a pair of points. And when x goes to minus infinity, our function is approaching to this line. So we don't know. That's why we put a pair of points. And then you decide which points make more sense. Okay? Now it's time to connect all the points together. And you always start near the origin. See? Near the origin. These 2 points, connect them. And then, oh, you see, looks like the bottom points make more sense. So you connect the bottom point and then you erase the top points. Okay? You erase the top points. And then here, connect them. Okay? So connect them. And then, oh, connect this point. So far, so good, everybody. This is problem 4. If you can understand problem 4, please type 4 in the chat. Good. Awesome. Thank you. So which problem you want me to go over next? So we did problem 3, problem 4, problem 6, and problem 7. Which problem do you want to go over next? 8. Oh, okay. So real world applications, yes. So we have formula, compound interest. So two formula you gotta memorize. So if we have, if we know the number of compoundings, then the formula A is principal times 1 plus annual interest rate over n. N is the number of compoundings raised to the power of n times t. Okay, and then if we know it compounds continuously, then we use the formula P times e to the RT. So these are the formula, and you gotta memorize it. Okay. So now let's see. 10,000, that's P. 5.5%, that's R. But R is 5.5% is the same as 0.055. Okay. After 7 years, 7 is the T. Compound monthly, monthly. How many months in 1 year? 12, right? Now we know all the information. Plug in. P, see? P is 10,000. 1 plus R. R is 0.055. Over N. N is 12. Raised to the power N. N is 12. T. T is 7. Okay? So put this in your calculator. How do you do that? Where's my calculator? 1000. Yes. And then multiply by parentheses. 1 plus R. R is 0.055 divided by 12. And then parentheses. Raised to the power of, where is my raised to the power of? E? Where is my power? Oh, right here. Okay. Raised to the power of nt. So n is 12 times. Oh, you see? My times should be on the exponent. So delete that. Go back there. Times. Ooh, but you see my my calculator, it does not allow me to put the times on the exponent. That means what I need to do, I need a parentheses. Then now I can put the times 7 and then close parentheses. So I get 14683.22. 14683.22. Okay. Yeah, so in when you type in your calculator, you probably remember the parentheses right here. Okay, so make sure you know how to use your calculator and get the same answer. Okay, part B, compounded continuously. So we use the second formula. A is P, P is 10,000. E to the R, R is 0.055. T, 7 years. And use your calculator. So, calculator. 10,000 times e to the R 0.055 times. Oh, you see my times, it moved my times down. I don't want that. I want the times to be in the exponent. So I need a parentheses, multiply by 7, close parentheses. See? 14696.14. 14696.14. So that's the answers. Okay, so make sure you remember these formulas for compound interest. So far, so good. If you can understand problem 8, could you type 8 in the chat? Awesome. Okay, what else you want to talk about? Do you want to talk about problem 9? Yes. Type yes in the chat. Yes? Okay, good, good, good. Awesome. Okay, so the number of rabbits in a farm is increasing according to the law of exponential growth. Law of exponential growth, the formula is population function, P of t. So this is population function. It equals to P0, which is the initial population, times e to the RT. R is the growth rate. Okay, the growth rate. Oh. All right, so we use this formula. Oh, and the problem tells us that initial population is 200 rabbits. So P0 is 200. And the population after 6 months. So this now we know the time has the unit months. Okay, and we also know the population after 6 months is 700 rabbits. Okay, and how many rabbits will there be after 1 year? Okay, so this information will help us to find the R. Okay, so we plug in. P of 6 is 700. You plug in T equal to 6. See, we compare. T equal to 6. P0 is 200. P0 is 200. E to the R. T is 6. Yeah, T is 6. Okay, now, so 700 equals 200. E to the R times 6. Both sides divided by 200. And then you see it's 7 over 2 on your left hand side. So we get 7 over 2 is e to the r times 6. To get rid of e, we apply ln. So ln of 7 over 2 is ln of e to the r times 6. ln and e cancel. So that's r times 6. Therefore, how do we find the r? Both sides divided by 6. So ln of 7 over 2 divided by 6. So this is the growth rate R. Do not plug into your calculator. Okay? We only use the calculator in the last step. So right now, just keep the number like this. So P of t. Now we can plug into our formula. P of t is P0, which is 200. E to the R. R is this number ln of 7 over 2 over 6 times t. Okay, so this is the formula. How many rabbits will there be after 1 year? 1 year, but our units for the time is months. So that's why I put the hint. How many months are there in 1 year? 12 months, right? 12 months. So we plug in t is 12. So 200 e to the ln 7 over 2 over 6 times 12. Okay, plug this in your calculator. And make sure you put the parentheses in the correct spots, right? So we put 200 times e to the, what? Let's see. ln 7 over 2. So e to the ln. Oh, let me put the parentheses first because a lot of things inside the ln. So ln 7 over 2. And then what's next? Over 6. See? 6 and 12 we can cancel, we get 2. So multiply by 2. Right here, multiply by 2. Okay, close parentheses. We get 2,450. So 2,450. So that's the number of rabbits after 1 year. Okay. What if, okay, what if I ask you, find the time, okay, when will the number of rabbits reach 3,000, something like that. Okay, what do you do with that? When means we're looking for the time. So we find the time t such that the population at that time is 3,000. So what do we do in this case? I don't have enough space. Let me shrink this little bit, and then I can have more space here. Okay. All right. Okay, so in this case, P of t, what's P of t? This is P of t. So P of t is 200. E to the ln of 7 over 2 over 6t is set it equal to 3,000. We want to solve for t. So isolate the exponential term. So divided by 200 on both sides. 200 cancel, hundreds cancel, 30 over 2 is 15. So e to the ln of 7 over 2 divided by 6t equals 15. To get rid of the e, we apply ln on both sides. So ln e to the ln 7 over 2 over 6t equals ln of 15. ln on e cancel. So we get ln of 7 over 2 over 6t equals ln of 15. How do we find the t? Both sides. See, both sides multiply by 6 and divided by ln of 7 over 2. So this is the time. Put into our calculator. Okay, so ln 15 oops, what am I doing? 15 and then times 6 over ln 7 half times 6 over ln of 7 half. Enter. 12.969. See? 12.969. About 13 months. Right? So, oh, wow. It increased so fast. You see? The 12 months, we have 2,450. And then about 30 months, our number will reach 3,000. So now I teach you two directions. I give you the months, you tell me the population. Or I give you the population, you tell me the time. So this is problem number 9. Do you understand problem number 9? If yes, could you type 9 in the chat? Awesome, thank you. So let's see, we did 9, we did 8, we did 7, we did 6. And what else that we miss? Do you want to do 5? Yes. Do you want to do number 5? Yes or no? Yes? Okay. All right. So find the domain. And what do we need to know? Domain. Okay. So domain, we have three type of functions that we need to consider. If you have square root of a, then we need the things inside the square root to be greater or equal to 0. And then if we have fractions, then we need the denominator is not 0. If we have ln, then we need the things inside the ln to be positive. So keep that in mind. Now come back to our problem. Let's check. Look at this term. Oh, you see we have log. Log and ln is the same thing, right? Then we need the things inside the log to be positive. Okay? Look at the second term. Do we have square roots? No, no square roots. But we have fraction. So we need the denominator not equal to 0. So the denominator 2x minus 3, 4x plus 5 not equal to 0. Now solve for x. So subtract 4 on both sides. 7x is greater than minus 4. Both sides divided by 7. So x is greater than negative 4 over 7. When you solve inequalities, be careful. When you add or subtract a number, it won't change the inequality. But when you multiply or divide it by a negative number, it will flip the inequality. So here, when we divide it by 7, 7 is positive, so it won't change the inequality. We still have greater than. But if we divide it by minus 7, it will flip the inequality, so the greater than will become less than. So just be careful when you work with inequalities. Okay, and then 2x minus 3 times 4x plus 5 not equal to 0. That means both factors cannot be 0. So 2x minus 3 cannot be 0. And 4x plus 5 cannot be 0. Solve for x. Add 3 on both sides. We get 2x equals to 3. Divided by 2. So we get x equals, not equal to 3 over 2. And here, subtract 5 on both sides, so 4x not equal to negative 5. Divided by 4, so x not equal to negative 5 over 4. Draw them. Real number line. Negative 4 over 7. Negative 4 over 7. Not include the endpoint, see? Greater than, not include the endpoint. We put an open circle at negative 4 over 7. And greater than, so on the right-hand side. Okay, x not equal to 3/2. 3/2 is bigger than negative 4 over 7. Not equal, so open circle. Negative 5 over 4. Negative 5 over 4 is less than negative 4 over 7. By the way, if you don't know whether that number is bigger or smaller, you can type into your calculator and then you get decimals. Then you realize, oh, this number is bigger than minus 1. This number is smaller than minus 1. So the negative 5 over 4 is on the left-hand side of negative 4 over 7. And then x cannot be that number, so we put an open circle. Therefore, our answer, open, negative 4 over 7 to 3 over 2, open, union, open, 3 over 2 to infinity. So this is the interval notation. Okay, do you understand problem 5? If yes, please type 5 in your chat. Thank you. Okay, so we did 5, we did 4, and we did 3. Good. So we only have 2 problems left. How about let's just finish it. So long division. Long division, what do we do? So this is in session 3.5, long division. 21x to the fourth plus 6x cubed minus 2x squared plus 2x minus 7 divided by 3x squared plus 1. Okay, then you ask, what multiplied by 3x squared to get 21x to the fourth? What multiplied by 3 to get 21? Oh, that's 7. What multiplied by x squared to get x to the fourth? That's x squared. Is that okay, everybody? And now, multiply them. 7 times 3, 21. X squared times x squared is x to the fourth. And then times 1. So that is 7x squared. And because it's x squared, so you put it under the square. Don't put it under the cube. Okay. Use the first line, subtract the second line. So this cancel. 6x squared, 6x cubed, right, stays here. Negative 2x squared minus 7 is negative 9x squared. And then the 2x and 7 stays here. Okay, we keep going. What multiplied by 3x squared to get 6x cubed? 3 times 2 is 6. X squared times x is x cubed. Okay, so now we distribute 2x times 3x squared is 6x cubed. 2x times 1 is 2x. Use the first line, subtract the second line. 6x cubed cancel. Negative 9x squared stays here. 2x minus 2x cancel. Negative 7 stays here. Okay. We keep going. What multiplied by 3x squared to get negative 9x squared? Negative 3, right? Negative 3 times 3, negative 9x squared. Negative 3 times 1, negative 3. Use the first line, subtract the second line. Minus 9x squared minus negative become plus, so they cancel. Negative 7 minus negative 3 become minus 7 plus 3. That is negative 4. So this is the remainder. Negative 4 is the remainder. And this is the quotient. So that means this giant division equals the quotient 7x squared plus 2x minus 3 plus the remainder, negative 4, over the divisor, 3x squared plus 1. Okay, so this is how we get that. And this is long division. If you can understand that, could you type 1 in the chat? Okay, good. Synthetic division. Synthetic division. Synthetic division only works when you see x minus c is a divisor. Okay, which means if you get 2x squared minus 1, you cannot use synthetic division. And if you have 2x plus 3, you cannot do synthetic division. It must have the form x minus c or x plus c. Okay, so when you have this, use long division. Okay, synthetic division. X minus c. Okay, so sorry, x plus 7. So the root is negative 7. Okay, so it's always opposite sign. So negative 7, put it here. 3x to the fourth, 18x cubed. You have to be very, very careful because if this is x to the fourth, this is x cubed, and then the next one should be x squared, but we don't have x squared, put 0. And the next one is x minus 5, and next one, the constant term, is the 30. So make sure you don't miss the 0. That's really, really important. Okay, now we go 3, put it down. 3 times negative 7 is minus 21, put it right here. 18 minus 21 is negative 3. Negative 3 times minus 7 is 21. Add them, 21. 21 times minus 7 is minus 7 times 2, 14, 7 times 1, 7. Add them, minus 152. Yeah, multiply by minus 7. Okay, I need calculator. Minus minus cancel, become positive, but I still need 7 times 152. 7 times 152 is 1064. Add them, see, it's 1094. This is the remainder. And these are the quotient. So you start with the last number, and then next number you increase the power of x. Next one, 3x squared. Next one, 3x cubed. You increase the power of x. So this is the quotient. So that means this equals to the quotient 3x cubed minus 3x squared plus 21x minus 152 plus the remainder 1094 divided by the divisor x plus 7. So this is our final answer. Okay, so let me check. Do I have the same answer here? Yes, we do. Okay, yes, we do. Okay, so this is part B. If you can understand part B, could you type B in the chat? Thank you. By the way, if you have questions, feel free to unmute and ask me. Okay? Almost finished. One problem left. The 2, we use the properties of log, right? We want to combine into a single log. So first thing you do is move all these coefficients on the power. So this is log 2x cubed minus 7 to the 6 over 5 plus log 4x squared plus 9 to the cube minus log 11x minus 2 to the 4th. So move all the coefficients up on the exponents and then combine them. Okay, combine into a single log. So single log. And here, if you see, well, then the first term, there's nothing, but you can imagine there's a plus in front of it. That's why you put these factors in the numerator. So 2x cubed minus 7 to the 6 over 5. We put it in the numerator. And then the next term is plus. See, we put this guy on the numerator. 4x squared plus 9 cubed. Next term, oh, minus. See, minus means we put it in the denominator. Okay. Typical mistake is student might put the log here, they put log here, the log here. No, we only have a single log. Really, a single log. LOG. You only see LOG one time. And then everything else is inside the big parentheses. Okay. So this is how to condense the expression into a single log. If you can understand that, could you type A in the chat? Thank you. Great. Okay, and then here, the reverse, right? We break them. So expand them into expression with a simpler log. So here, ln, if that factor is in the numerator, you kind of have plus in front of it. Okay, so but the plus, you don't need to write it down if this is the first term. So ln of 13x squared plus 7 to the 8. And then, do you see this term is in the denominator? So you put minus sign in front of it. And here, 7 roots. What 7 roots means? 7 roots is to the 1 over 7. Okay, 7 roots is to the 1 over 7. The power, the exponent, is 1 over 7. And then next factor is in the denominator. That's why still minus, put the minus sign in front. And this is 6x to the 5th plus 5 to the 9. Okay? We're ready. Move the exponent down in front. So 8 ln 13x squared plus 7. 1 over 7. Move in front. 4x minus 21. 9. Move in front. 9 ln of 6 x to the 5th plus 5. Okay, and that's it. We cannot do further. So we cannot move the 2 in front, or we cannot do, ln 13x 2, move it in front and say this is ln 7. No, we cannot do it. Okay, so once you split like that, we're done. Okay, so no further, because the ln, it can break the inner products into sum of ln's. It can break the division into subtractions. But here, the inside the ln is plus. We cannot break it anymore. Okay, if it's a product or division, we can break it. But if it's sum or difference, we cannot break it further. So this is as far as we can get. All right, so this is part B. If you can understand part B, could you type B in the chat? Awesome. So I believe we have finished all the problems on the practice exams. Do you have other problems on your homework or whatever in class notes or quiz? Do you have any questions? No? If you have questions, please feel free to unmute. No questions. Thank you. So, yes, I have recorded the session. So let me stop the recording.